In this lesson, we're going to talk about network access control. Network access control, or NAC, is used to protect your network from both known and unknown devices by scanning any devices to determine its current state of security prior to being allowed access to your network. Network access control can be used for computers that are within your internal network that are physically located in your buildings and connected to it, or it can be applied to devices that are connected into your network remotely through a VPN. When a device attempts to connect to a network, it is placed into a virtual holding area while it's being scanned. This scan can be extremely simple, like verifying that it has the basic authentication using EAP, for example, or it can be more intense. For example, the device can be checked for a number of different factors, including its antivirus definitions, to make sure that they're up to date, the status of the security patching, and other items that might introduce security threats into the network if you allowed it to connect. If a device passes this inspection, it is then allowed to enter and receive access to all of the organizational resources that are provided by your network. If the device fails the inspection, though, it is instead placed into a digital quarantine area and it awaits remediation. While it is in this area, the device can receive its antivirus updates, it can get its operating system patches, and any other security configurations and services that it might need. But it can't logically communicate with other portions of the network because it is trapped inside of this screen subnet that is reserved for quarantine devices. Like a bad child, the device has been placed in timeout until it can be rehabilitated and meet the requirements of the initial NAC inspection. Once it successfully meets those requirements, it is then moved into the network and receives full access again to your organizational resources. NAC solutions can run either using persistent or non-persistent agents. Persistent agents are a piece of software that's installed on the device that's requesting access to the network. This works well in a corporate environment because the organization owns all the devices and controls their software baselines, but it doesn't work really well if you're using an environment where people bring their own devices. Instead, you might want to use a non-persistent agent for this. A non-persistent agent solution is very popular in college campuses where people bring their own devices and connect them to the network. These solutions require the users to connect to the network, usually over Wi-Fi, and then they go to a web-based captive portal for login and they have to click a link. Once they click that link, the link then downloads an agent onto the computer, scans the device for compliance, and deletes itself from the user machine once it's done with the inspection. Network access control can be offered as a hardware or software solution when being implemented in your networks. One of the most commonly used network access control mechanisms is called IEEE standard 802.1x, which is used in a port-based network access control. Most modern NACs will be built upon top of the 802.1x standard, using additional features and capabilities as well. In addition to the NAC health policy, there can also be different rule-based methods that you can use for granting or denying access to your network using NAC. There's more than just the health policy though. This includes things like time, location, role, or rule-based methods to check a device for entry to the network. With time-based factors, we will define access periods using a time-based schedule. For example, you might work in a company that only operates from 9 to 5, so if you try to log in at 2 in the morning, you could be denied access. You have to be careful when you implement these time-based approaches since you could end up blocking legitimate access by mistake. In our company, we have employees who work on both sides of the world, and so while I'm sleeping at 2 in the morning, some of the employees are over in Asia trying to access our networks. We can make it so that they can only access our systems during their daytime hours and that we can only access our systems during our daytime hours if we want to use a time-based model. With location-based factors, we're going to evaluate the location of the endpoint requesting access using geolocation of its IP, its GPS, or other mechanism. For example, if I know that one of the employees always logs in from Florida, but now all of a sudden their login credentials are being logged in from Italy, that would be something that would be flagged, and we might put them into remediation until we figure out if they're really the right person. After all, maybe that person is on vacation and they're accessing their work email from Italy, or maybe someone hacked their credentials and they're trying to log in as them. Both of those would be things that we could catch using location-based access. With role-based factors, we can reevaluate a device authorization when it's being used to do something. This is known as adaptive NAC. For example, if your device tries to join a subnet that's used for server management and is on a user account and a user laptop, it should be rejected. But if I try to connect a server to that domain, it will allow that to happen because that is an authorized function based on the role of that device. By using this adaptive NAC, we're able to look at the role of the device and figure out if it's something that it should or should not be allowed to do. With rule-based factors, we can use a complex admission-based policy that might enforce a series of rules, and we basically write them with a bunch of logical statements. If this, then this. If this, and this. If this, or this. For example, if Jamario is an instructor, let him access this thing. If Jamario is a student, deny him access. That's the idea of a rule-based NAC. Now, that's obviously a very simple example, but hopefully you get the idea. Our goal is to make policy based on series of rules and then allow or deny people based on those things. So remember, network access control, or NAC, is used to protect your network from both known and unknown devices by scanning any devices to determine their current state of security prior to being allowed access to your network. As you can see, NAC is very useful as part of our defense in-depth strategy and helps to enforce zero trust architecture within our networks.